Hello, everyone. I'm really happy to be here for the first time at this conference and for a long time in computer vision conference. And also didn't present for a while, so please stay with me. So I will be presenting another perspective as YOLO Ultralytics has everything built in, so how to do it differently. Not necessarily you have to, but interesting to know that there are other options. So I was already introduced, so I won't repeat this slide anymore. And what I have prepared for you was a short demo with oriented bounding boxes detection. First, just how it's done so far with Ultralytics, just one line, which is cool. Then how to do it more complex when you want to gain some more control on what you are trying to reach. And if you are like more researcher or developer who wants to have hands-on and full control of everything. And I think I lost the internet connection, so I will just try to do online demo offline, so just showing the notebook I have prepared, and hopefully you will learn something from this presentation. First, I would just repeat what was mentioned already a few times. So my journey with open source started many years ago as a PhD student, and when I wanted to share what I did, and not only paper, which is usually forgotten, so I was starting to share my code. That's how I got to the open source. I contributed there, then I found some interesting projects. So it was PyTorch Lightning. I think I already met Glenn a few times with YOLO 3, YOLO 5. I maybe skipped the 8 and 11 yet, but that's something it may change. I believe that the open source and community is a huge drive how to improve everything, not only AI, but any software development with three main points, like collaborative integration. You can collaborate with anyone everywhere across the world. Doesn't matter what your education or what are other biases. Then it brings a big transparency and reproducibility because everyone sees the code, everyone sees what you are doing, and everyone can help and also provide the critical feedback. And what's important, don't take it, critical feedback is constructive thing. It's not that someone doesn't like you, but it tries to help you. That's the important thinking which everyone should have. And reliability, because if you have a product which is public, used, and has many stars, so it means that many people use it, so you can rely that it's good and it works as expected. You would not expect any issues anywhere in the pipeline. So some nice projects, so Ultralytics is one of them, which is very nice for democratizing the computer vision. Then PyTorch Lightning is a really great tool for scaling training in scale. And one more platform is a Kaggle, for example, when you want to share. They provide you the data, and you can just play with the data and learn how to solve some tasks. So oriented bounding boxes, so everyone knows object detection in bounding boxes. It's standard and trivial, so I try to step further, but not too far. So oriented bounding boxes is a task when you have better fit for the bounding box, right? So you add one more parameter, which is angle, and then you can reduce a lot of background from the images, as you can see from the data set over here. So just shifting the bounding box, you can reduce, for example, for the planes on the top right corner, a significant amount of background, and then the detection is much more reliable. In industry, it would be very good boost because you don't need necessarily segmentation, but oriented bounding boxes for the specific task is a really great thing. So this is a screenshot from the documentation, and I really tried it, and it really works. So it's cool. So you can just, in a few lines, train the model with some predefined data set, even if you have, or you can probably add some of your own, which is great. So very nice way how to really get soon hands-on what you are doing and what you want to solve eventually. And what I'm going to share is, okay, there could be a different way. So what PyTorch Lightning is focusing on how to train the model. So eventually, as Ultralytics is focusing on the models and how to solve specific tasks, which is great. So it can also blend with a different tool, which is focusing how to train. And kind of don't need to bother with everything code-related, distribution-related, and those stuff. And it's also open source, so anyone can use it, read it, and learn how we do it. So I hope I did the small table on the bottom correctly. So YOLO Ultralytics already have all those capabilities, but they are kind of boxed with certain parameters, which is important if you want to reach good results, and if you want to guarantee the good results. So what we can also, if you are interested in more developing, so we can also kind of separate this one big box to small boxes and get more control, more hands-on, more curiosity what's happening in every stage. So what the architecture for which PyTorch Lightning is standing for is separating data, model, and training loop. Pretty much that every part you can switch or you can customize, and you don't need to think about, okay, do I need to blend this one to the previous loop, or how to do it? So what I have prepared is, and then it brings the reproducibility and debugging. So the part is that you can focus on the model, for example, and then the training is kind of tested, well tested, and you can rely it works fine. Or you can focus on the data and then use YOLO models and just focus on your task to be solved. Or you can just do some minor tweaks to your model, just inherit it, do some small changes, add, remove layer, whatever, and then train it with the standard Ultralytics dataset again. So this can just split those 3 steps to independent tasks, let's say. Yeah, okay. So, and then the classes which we have, so it's Lightning data module, which is covering the data part, Lightning model, which I use as a wrapper to the YOLO model. So I don't invent the wheel. I will be using the YOLO model. I would be using YOLO criterion for optimization, and then just add optimizer and some small stuff around it. So basically, the data model requires certain steps. You need to be set up. So for example, if you run on multi-GPU training, so for each node, you would need to eventually download the dataset if it's not ready yet. Then you define how the training data loader is created, and then when you don't need to bother how it's moved to the GPU or any device, then the trainer is giving it to you automatically. So it gives you, in the end, batch data shuffled and GPU ready, TPU ready, or any device which is the training loop running on. Then the model, so Lightning model would be just encapsulating the Lightning model inside. Then you need to define what's the training step, the validation step, and configure optimizer or scheduler if needed. And then the training loop is running with the standard trainer, and then has certain parameters. You can define if it's DDP, FSDP, what's the precision, if it's mixed precision, or if it's bfloat 16, whatever it's supported with the trainer. Or eventually you can write your own strategies, or you can write own precision for your device or your hardware. So everything could be customized as you wish. And this gives you the 3rd step of the training. So I will switch to the notebook when I first, again, just show the data set, what I have, then the data module, the model for the training, and run how I train it when I was online. So, okay, let me go to the top. So I found another good part about Ultralytics that they provide the data set straight away, even if it's smaller, not the original size. But I spent like almost a day trying to download it and make it right. Then I switched to this one because I was short of time, and it's nice, it works, it's nice, optimized. So it's a good starting point for sure, which provides the data as images and labels, also converted labels to the relative size, which is also, people may forget sometimes. Then the dataset I have here, so I created dataset as another class, so to simplify the training, and this is simple Torch dataset, so nothing new, and define how you get the sample, how you convert the coordinates, because the original size is XY and you need to add the angle for the training, and some drawing for the bounding boxes. So what I like at every stage to get some visualization, so I know that I'm right, that I don't accumulate the bug. And that's also one nice part about splitting the training into data, model, and training, that at each stage you can wrap it and revisit that everything is correct. So I have created the data set here and just took one sample with the drawing, so I know approximately what the data are. and it gives me confidence that I would be training something which is relatively fine. Don't make too much mess at the beginning. If you mess any of the stage and you just look at the end, so it's very hard to find where the bug is. So for me, it's usually important to make some visualization or validation at every stage to understand that everything is fine. And then going to the data module part. So I already prepared the data script because I have downloaded it manually before. And I have collide function, which is converting the labels and images as expected. And then I have the training loader, validation, and test loader. So you see I'm using the data set before and just adding some parameters to get what I have. And again, adding small print, so I see that it gives me the images in the right dimension. Also some small print for the dataset annotation, which I have there. And it makes sense. I don't have visualization for this one, but I can see that those numbers pretty much align what I would be expecting. Then for the model part, it was a bit tricky, as it was everything encapsulated inside, so I tried to kind of distillate the model part and some stuff around. So there's a bit more code than you would expect, but that was just to make it running correctly. So you create the Lightning model as a wrapper around the model. So I pass it to the model, and I had to switch to the training mode, and then, then the step, so pretty much the validation and training has very common parts, so I created one more function which is step, and it just returned the loss. For validation, you would also add accuracy, or you can add accuracy or for any other step, but this is just to don't duplicate the code for validation and train, as it is part of the same pipeline. So then in the training step, I have raw prediction, target loss. Then I do the manual step in this case and return loss. Then for the validation step, I return again loss. So it's used for logging in the end, and you can better see what's the progress of your training. And again, just to have the model created at the same cell, so I know that I don't have any syntax issue and everything is working fine. And the last step is in this part, the trainer. So I initiate the trainer and a small CSV logger. So for example, for me, I prefer, when I work with notebooks, I prefer to use the CSV logger, as you can just dump it to the file and you can easily attach it to, straight to the notebook and save it, compared to if you use default TensorBoard, which is about 20 megabytes attached to the notebook, that otherwise would have like half megabyte. So so that's why I use the simple CSV logger here. And then the training is on device auto, as I was developing the notebook on CPU, then I was running the training on GPU. That's a nice part about the PyTorch Lightning, that you can, with the same code base, you can debug it on one device and just with easy switch, or even with this auto mode, just switch to any device you want. And for example, what I believe that Ultralytics doesn't have yet the bfloat 16 precision. So with this trainer, you can just easily run bfloat 16 through. You can run distributed training, so you can add how many devices you have. And if I would be online, I would show it also on the multi-GPU or multi-machine training as Lightning AI platform offers, but maybe later or offline with anyone who is interested. And then you create the trainer, you run fit for the model I created before, data module I created before, and show the sample outputs, run the training, and I ran it for 10 epochs without crash. So I was happy about it. I didn't plot the loss yet, so it would be also important to see how the loss progress or anything, or some more tweaks somewhere. So this is the notebook I have prepared. And just jumping back for the last slide, that is about some suggestions. So for me, as I already commented during the notebook session, so visibility and transparency is one of the key points for me, which I do, and I think it's really useful. Then what's nice for the PyTorch Lightning that you really abstracted the training parameters. So you don't, and it's also well tested. So it's tested on general cases, not specifically for YOLO, but you can believe that it's working well. As I had a meeting yesterday with one of my colleagues, and previous ex-colleagues, and he's working in graphical company, and he said, oh, we use Lightning still. So you can rely that it's used in production and it's well tested, and you can really focus on the important part, which is if you are research engineer, so you focus on the model. If you are product engineer, so you focus on the data and you rely on the previous boxes or previous methods which are provided for you. Then, yeah, and everything is open source, so you can just easily step to the code, see if it's correct, or you can suggest that should be fixed, it could be improved, whatever you want. And yeah, happy to share this one later on if you are interested, and really happy to learn what are the practical cases, what people are using it. Thank you.